Statistics with SQL. Create table and load data. After we connect to SQL Server, we see a list of objects in the right window of the SQL Server Management Studio. As we will create new objects, we will populate this list. At first, we need to create a new database. For that, we will open a new window for SQL queries. We can click on the New Query button by hitting Control key plus N. In the new window, we will type in an SQL command for creating databases with the new database name. Create table SNP 500. And close the statement with Go to create a query package. Go statement is not a must if you are using an SQL server. However, in larger SQL codes, the use of a Go statement improves server performance, allows undos, and eases code readability. So it is a good practice to use Go in your SQL code. To execute the SQL command, we select the SQL code snippet and click Execute. To refresh the list of databases, we right-click on the word Database and select Refresh. After refresh, the new SNP database shows up in the database list. When we connected to the SQL server, the default database was Master. This is a system database which exists on every SQL server. Since we are going to execute SQL queries on our new database, we need to switch the active database to our SNP 500. In SQL Server Management Studio, we can do that with the drop-down menu. The same action can be accomplished with the SQL statement Use SNP 500. Note that after we execute this statement, the active database name in the menu changed from Master to SNP 500. Next, we will create a new table, Company by Sector. At first, we will create the table structure with the Create Table command. Here we must specify new column names and column data types. The numbers in the data type brackets show maximum length allocated for the values in the column. For example, varchar 5 for ticker means that ticker string could not be longer than 5 characters. Varchar 50 for the company name means that the company name string cannot be longer than 50 characters. If you do not know what length to expect, just type the word max in the brackets. Execute the Create Table command. Expand the SNP 500 database object. Expand the list of tables. Expand the Company by Sector table object. Expand the list of columns and ensure the columns were created as described in the Create Table command. Now it's time to populate the table with the data. For that, we will use SQL command bulk insert. We will load the data from the text file with commas separating values. In the bulk command, we have to specify the path to the file with the data, the row number where the data starts. In our case, the first row in the file is reserved for column headers. Also, we need to specify the column field and row delimiters. Tab lock statement restricts the access to the table while the data is loading. In our CSV file, the first row has the column headers. The number of columns and the data types in the created table should match the number of columns, their order, and data types in the file. Otherwise, the SQL server will generate an error and will not load data into the table. After the command is executed and the data is successfully loaded, the SQL server reports how many rows were loaded. In our case, all 505 rows were successfully loaded. To check the data, we can right-click on the table name. And then click Select Top 1000 Rows in the drop menu. The SQL server will automatically create a Select SQL query in the new query window and execute it. As a result, we will see the content of the table in the message window. Alternatively, we could write the same select query by hands and execute it with the Execute button or F5 key. The Company by Name table includes columns for the ticker, company name, sector, stock price, and is populated with data from our CSV file. We will be using this table to demonstrate how to use SQL for data analysis. Count, min, max, top, and distinct. After we connect to our SQL server with the SQL Server Management Studio, we see the list of objects in the Object Explorer window to the left. If we expand the cascade of menus under the database object, we will find the previously created table. Clicking the New Query button will open the new window for SQL commands. One thing to pay attention to here is that the default database is master. We need to select our database from the drop-down menu. Alternatively, we could run the use command. The first command we will execute is the select query with asterisk that lists all values from all columns in the table. The results of the query execution are shown in the new window below. Often, for the data overview, we need only the first several rows instead of retrieving all of them. This is especially useful when working with large tables. The top command will restrict the select statement to the first 10 rows. After we execute the select statement with the top command, the result window will show the first 10 rows of the table. Now we will show some basic aggregate functions. The first function is count. The following count command counts the number of rows in the table, which is the number of companies. If we want to count the number of companies in each business sector, then we can use the Group By clause. Here we indicate that we want to count all companies in each sector with the Group By Sector statement. We can assign a name to the second column with the counts. Here we will call it as number. The results window shows a table with two columns, sector name and the number of companies in this sector that we found in our data. Now let's look at a couple other aggregate functions that are commonly used. Those are the max and the min functions. Let's say we want to know what the highest stock price in our table is. We will use select statement with the max function. We will name the new column as max stock price. Similar statement structure can be used to find the lowest stock price in the table. For that, we will use min function instead of max and name the new column min stock price. As before, the result window shows the result of the query execution. Sometimes we want to see both the max and the min values at the same time. No problem. For that, we can include both the max and the min in the same select statement and execute it. Notice that the maximum and the minimum both returned in the result window. Just as we can count rows in groups, we can also apply the max and min functions to groups of subsets of rows. With the following select statement, we can find the minimum and maximum stock price for companies in each business segment. Note that we will not only group by segment, but also include the segment name in the results. Another command that you will often meet in select statements is called distinct. For example, if you will select names of the sectors from your table, you will get a number of duplicating records. To reduce the number of records by removing duplicates, you can use the select statement with distinct command. As you can see in the results window, the reported list of sector names does not have duplicates and only has unique names. This simple yet powerful command will help you deal with redundant data in your data scientist's work. Statistical functions in SQL. Data scientists often use statistics to better understand datasets. SQL includes functions for describing datasets. We will cover the most commonly used statistic functions: sum, average, variance and variance estimator, standard deviation, and its estimator. The most commonly used function is sum. The sum of a column returns the algebraic sum of all values in the column. Note here that your values have to be numbers. If your values are stored as characters, you need to convert it to a number format like integer, decimal, real, or other. The next popular function is average. In SQL, average is the algebraic sum of all values in the column divided by the number of rows. Empty rows do not count. Functions for calculating variance are not so obvious and have to be explained. Variance is a good way of measuring how spread out the data is. SQL has two functions for calculating variance: varp and var. The difference is that varp calculates the variance of the data you have, while var estimates the variance of the whole data you could have. Imagine you want to know the variance of the water consumption per household in your city. You have the data for one district only. The function varp will calculate for you the variance of your existing data. Here it is a variance of the water consumption per household in the district. In math language, varp calculates statistical variance for the population. P in the function name stands for population of data you have. If you want to estimate variance of the water consumption per household for the whole city, based on the data for only one district, then use var function. Note that the functions differ only in the denominator. Varp has n in the denominator, while var has n minus 1 and will return greater values than varp by default. Remember that var is an estimator and use it with care. In most of your applications, you will use the varp function for calculating variance of your data. Similar notations are true for standard deviation functions in SQL. Standard deviation is a more commonly used statistic for understanding the distribution of data. Function stdevp returns standard deviation of your data, while stdev function returns an estimator of the standard deviation of the data you could have if you continued to collect it. In some sense, the stdev function is trying to predict the standard deviation of all possible values of the variable. Sometimes you will hear that stdev is biased and stdevp is an unbiased standard deviation estimator. The bottom line: use stdevp function for calculating standard deviations in SQL and report it as the standard deviation of the data we have, unless you really need the standard deviation estimator. Now, let's see how to apply these statistical functions in practice. For that, we connect to our SQL Server with the SQL Server Management Studio and click New Query button. Since the table we will be working with is in the S&P 500 database, we select this database in the database list. At first, we ensure that the table has the data we are going to work with. With the Select Asterisk query, we can view the table content in the Results window. Next, we calculate the sum of all values in the stock price column with the sum function. In this example, we use the table with the stock prices for the sake of consistency with the previous exercises. We can calculate subsums of the stock price variable by the business sector. For that, we will use Group By clause. Remember to include the sector variable name in the select statement. Now we add the average function to the select statement and calculate average stock price for each business sector and report it in the same output table. Similar select statements with varp and var functions returns variance and its estimator for the stock price variable. Replacing functions for variance with the functions for standard deviation, we calculate standard deviation and its estimator for the stock price. The reported values are grouped by sector in the same manner as previously. Let's calculate the average values again. Note that the reported values for the average stock price has a lot of digits in the scale part. We can round the average stock price values using the round function. Here we round average values to hundredth part. For that, we set the second argument of the round function equal to 2. If we would like to round to thousandth part, then we would set it to 3 and so on. However, we still have the trailing zeros in the average price values. The problem is that in SQL, the average function returns the average value with default decimal places, which can be different for the variable format. To solve this, we use cast function. Cast function can convert SQL variables from one format to another. There is one more function for that, called convert, that does the same conversions as cast, but also can apply styles, which is useful in converting dates. Now, after we applied the cast function, we converted the average values to the same decimal format as we have for the stock price variable.